Hi, this is Alex from devstories.eu. Pydantic, Data Validation, Episode 8 of 20. When a field is annotated as a union of a string or an integer, and you pass the integer 1, 2, 3, which validation does Pydantic actually attempt first? If you assume it just reads your code from left to right, you might be surprised when your data behaves differently than expected. This brings us to union types and smart validation. A union type allows a single field to accept multiple distinct data types. Validating unions is inherently complex because Pydantic actively tries to coerce data into the requested type. An integer can easily become a string, and a string containing digits can be parsed into an integer. If the validation engine simply took the first match it found, your output would change entirely based on the arbitrary order you listed the types in your code. This rigid behavior does exist, and it is called left-to-right mode. In this mode, the system evaluates the input against the first type defined in the union. If validation succeeds, it stops immediately. If it fails, it moves to the second type. If your field is typed as string or integer in that order, and you pass the integer 1, 2, 3, left-to-right mode evaluates the string condition first. Because the integer 1, 2, 3 can be seamlessly coerced into the string 1, 2, 3, validation passes. Your integer is silently converted into a string solely because string was written first in the union. Here is the key insight. By default, Pydantic avoids this trap by using smart mode. Instead of stopping at the first possible match, smart mode evaluates the input against all the possible types in the union. It then compares the successful validations and picks the best match based on specific scoring criteria. The primary criterion for simple types is exactness. Smart mode heavily penalizes data coercion. Going back to our previous scenario with a field typed as string or integer, when you pass the integer 1, 2, 3, smart mode tests both options. It acknowledges that the input could be coerced into a valid string, but it also sees that the input is already a perfect exact match for an integer. Because an exact match always outscores a coerced match, smart mode correctly returns the integer 1, 2, 3, regardless of which type was written first in the union. When your union contains complex data models rather than basic types, smart mode relies on a different metric. It counts the number of valid fields set. The engine evaluates the input dictionary against every model in the union. It calculates how many fields in the input exactly map to the defined fields of each model. The model that successfully absorbs the highest number of input fields without throwing validation errors is declared the winner. This prevents a smaller, less specific model from swallowing data that was clearly intended for a larger, more detailed model in the same union. Smart validation ensures your data retains its precise original shape whenever possible, protecting you from silent coercion errors that are notoriously difficult to track down in production. Thanks for listening. Happy coding, everyone.